The LI for this lesson is to be able to calculate resultant forces by adding vectors. We saw back in chapter 8 about how we can write forces as vectors using the I and J notation, or as column vectors. Remember, if I said there was a force of 1I and 1J, that is, I is the horizontal direction, so that is our I vector, and J is the vertical direction. So 1I plus 1J I could write as a column, 1 being 1 to the right and 1 up is the same thing. And we can find the resultant of two or more forces by adding the vectors. So if I told you two forces in vector form, you can add them together, which gives you the resultant of those forces. And if a particle is in equilibrium, the resultant vector force will be 0I plus 0J. And let's highlight that. We said that equilibrium is when all the forces are equal, everything sort of cancels itself out, and there's no resultant force. So it makes sense that the resultant force as a vector would just be 0I and 0J. There is no resultant. So example 3. It says the force is 2I plus 3J, 4I minus J, minus 3I plus 2J, and AI plus BJ act on an object in equilibrium. If I tried to do a diagram of that, I'd have arrows going all over the place. Find the values of A and B. Well, we just said that in equilibrium, there'll be no resultant force. So if I add up all of the forces acting on that object, I should end up with 0. I'm going to do it in column form because I prefer column. If you want to keep it in I and J form, that is fine as well. 2I plus 3J in column form is just 2, 3. Plus 4I and minus J, so 4 and minus 1. Plus minus 3I and 2J. Plus AI and BJ. And it's going to give me the resultant of 0, 0, no resultant force, because it's in equilibrium. So remember, equilibrium in the question, straight away we should be thinking no resultant force. So I'm going to add these together. So I've got 2, add 4, add negative 3, add A is going to give me 0. So let's write that out actually the long way. 2 add 4, add negative 3, add A is equal to 0. Well, that's 6, take away 3 is 3. So 3 plus A equals 0. So clearly I can see that A is going to be negative 3. Now let's look at the bottom of these. So I've got 3 plus negative 1 plus 2 plus B is equal to 0. Added up these bottoms. And let's do 3, take away 1 is 2, add 2, so 4 plus B is equal to 0. And therefore B is going to be negative 4. So that is my values of A and B. That's what I was asked to find out in the question. Example 4 is slightly different. So it tells us again that I represents the unit vector due east. So that's just saying that I is that horizontal vector to the right. And that J represents the unit vector due north. So just like we've done up here, that's the J vector. And remember, unit means 1. So one I is just 1 unit to the right. 2 I's would obviously be 2 units to the right. It says a particle begins at rest at the origin. It is acted on by 3 forces, 2I plus J, 3I minus 2J, and minus I plus 4J. These N's are newtons, so it's saying 2I plus J newtons, just the unit of force. And find the resultant force in the form PI plus QJ. Well, that just means we need to add up these forces together. So part A, I'm just going to add them up. I'm again going to do it in column vector because I prefer it, but you could just still do it in I's and J's if you want to. 2I plus J, so that's just 2 and 1 as a column vector. Add 3I and negative 2J. Add on to that negative I, so negative 1, plus 4J. Well, 2 plus 3 take away is going to be 4, and 1 take away 2 plus 4 is going to be 3. So that is my resultant force, 3 newtons. And because it told me in the form PI plus QJ, I'm going to write it then as 4I plus 3J newtons, because that's how I was asked to do it. And actually, if in an exam, I would probably also add, just so the examiner definitely knows I know what I'm talking about, I would probably put just down here that P is equal to 4. So where they ask for P, that is a 4, and that Q is equal to 3. Just so you can see that I've definitely got my answer in there. Then it says work out the magnitude and bearing of the resultant force. So this is my resultant force here. Now let's have a think about that. If I've got an object and it is being acted on by the force 4I plus 3J. Well, I know, let's see what colour should I do this in. 4I is 4 to the right, so that's my 4I. And 3J is 3 upwards, 3 to the north. So my force, my resultant force, looks something like this. That is going to be my resultant force in that direction. First it says work out the magnitude of the resultant force. Well, the magnitude of the force, I'm going to call it force F, the magnitude of my resultant force is going to be just using Pythagoras, the square root of 4 squared plus 3 squared. And you should be able to recognise that is a Pythagorean triple we've got, so it's going to be 5. So 5 newtons is the magnitude of that resultant force. Then it says work out the bearing. Now, you might need to flick back to your GCSE notes on this one to remind yourself what a bearing is. But bearings are always measured from north, they are measured clockwise, and they'll always have 3 figures. So what I'm looking for is I'm looking for this angle here. That's my theta that I'm looking for. But actually it's probably easier if we work out first this angle inside the triangle, and then I can just do 90, take away that angle to work out the bearing angle that I'm looking for. So I'm just going to think about this angle. If I want to find alpha, well, I know that tan alpha is equal to opposite over adjacent, so 3 over 4. So alpha is equal to inverse tan of 3 over 4. Now I've left my calculator over there, so I'm going to have to cheat and quickly check. So that will give me 36.9 degrees. Obviously you would do that on your calculator, 36.9 degrees. That's not my answer though, because remember I'm looking for theta, not alpha. So to find theta, I'm going to do 90, take away that 36.9 degrees, which gives me an answer of 53.1 degrees. Now remember though that it needs to be a bearing, so it must be a 3-figure bearing. So I am going to say that the bearing is 0.53 degrees. Remember, I've got to put that 0 in front. So what have I got? I got my magnitude was 5 newtons and the bearing of that resultant. And then finally, part C says, describe the motion of the particle. And as we looked at before, we said if there is a resultant force, so the object's not in equilibrium because there is a resultant force, then it's going to accelerate in the direction of the resultant force. So that's all I'm going to say is particle accelerates in the direction of the resultant force. And that's my answer. Now, having done those 2 examples, you should be able to have a go at exercise 10b now, which is adding up these vectors, so adding up your I and j vectors to find the resultant force.